Welcome. So today we're continuing with solving inequalities using addition and subtraction. So the warm-up is just like what we did yesterday. We want to solve and graph the inequality x minus 4 is greater than 10. So the first thing I'm going to do is I'm going to ask myself, okay, I have x minus 4. How do I undo subtracting 4? I'm going to add 4. So I'll rewrite x minus 4 greater than 10 on both sides. Right, and then my goal is I want to undo that subtracting 4, so I have to add 4. Add 4 over here, add 4 over here to keep my inequality true. 10 plus 4 is 14, so that's what I get on the right. Here I have negative 4 minus 4 plus 4. That becomes 0. So x plus 0, or just x, is greater than 14. All right, so that's my solution. That means that for any value that's greater than 14, it's going to make my inequality true. So like 15 is greater than 14. So if I take 15 minus 4, I'll get 11, and that is greater than 10. So that's making my inequality true. I could pick 16. Right? That's going to give me 12. That's greater than 10. So any value that's greater than 14 makes my inequality true, so it's a solution. So then I'm going to come over here and I want to graph it. Okay. So I'm going to go here. I have 13, 14, and 15 that I put on my number line. Since I have greater than, I don't have greater than or equal to, I'm going to put an open circle here at 14. And then since it's greater than, I want to move to the right where numbers are getting bigger. So I'm going to take what I have and I'm going to move to the right. That's going to be the graph of my solution. X is greater than 14. It's all possible values, all numbers that are greater than 14. That's what I graphed here, and that's what makes my inequality true. All right, so today we're going to look at more examples. But before we do that, I just want to help you all with translating between words and inequality symbols, which I know can be challenging. We're going to translate between words and inequality symbols. So that's when we have word problems. This is going to help us know which inequality symbol we should use. So for the less than sign, of course, when we see less than in a word problem, that's going to signal we should use the less than inequality. Though a synonym is below, so if we're saying like, oh, it's going to be below 5, that means it's going to be less than 5. And then fewer than, when we're counting things, is another synonym or translation between the symbol less than. All right, so then for greater than, we'll have more than, greater than, and above. Right, so just like we had below, if something's going to be above 5, that means it's going to be greater than 5. Okay, so now we have less than or equal to. For less than or equal to, we have at most, no more than, not above, and maximum or limit. So we're going to have less than or equal to. If something says at most 5, it's going to be 5 or less than 5. So that's why it's less than or equal to. Same with no more than, not above, and the maximum, right? Our maximum is 5, so it can be 5 or it needs to be less than 5. And then we kind of have the reverse for greater than or equal to. So for greater than or equal to, we have at least. So if you see at least 5, it needs to be 5 or greater. No fewer than 5, 5 or greater. No less than 5, 5 or greater. And there's a minimum of 5, right? So 5 is at lowest, and then it's only going up from there. So take a minute to write all those down. I'm going to keep going, but if you haven't finished writing them down, then just pause the video. All right, so now we're going to look at what's example 3 from the book, and our third example as a whole class. So solve the inequality x minus 1/2 is less than negative 2/3. So we have fractions here, which sometimes scare us, but nothing's changing. And if we have a calculator, there's absolutely no reason to be worried. So I have x minus 1/2 is less than negative 2/3. And I need to ask myself, what is happening to the x? Well, x is getting subtracted by 1/2. So I'm going to undo that by adding 1/2. And of course, if I do it to one side of an equation or an inequality, I have to do it to the other. Okay, so negative 1/2 plus 1/2, that's just 0. So I get x on the left-hand side, as I wanted to. And then I can do this off to the side. 2/3 is the same thing as 4/6, and 1/2 is the same thing as 3/6. We do negative 4/6 plus positive 3/6, we get negative 1/6. Or most of the time, you could just do that on a calculator. Okay, so we'll add those, we get x is less than negative 1/6. So we solved the inequality, great. Now we need to graph the solution. So I'll just put that in the middle, negative 1/6. It's not crucial, the other numbers we have around it. We could count by 1/6, we could just count up 1, down 1. I'll go by 1/6, so we'll say back here is negative 2/6, and over here is 0. That's what's going to get when you add 1/6. All right, so this is less than 1/6, so that's going to be an open circle, an open point, a negative 1/6. And then I'm moving left because it should be less than. So when it's less than, I'm moving left in the negative direction. So no different, I just happen to have fractions. Okay, now I want you to try this one. It's really, really similar, right? N minus 1 3/4 is less than or equal to negative 5/8. So go ahead and try it, just like the one we just did. Pause it, do the problem, and then we'll come back. All right, good job. So this is what you should have. You should get n is less than or equal to 1 1/8. So since I was subtracting 1 3/4, I need to undo that by adding 1 3/4 to both sides of the inequality. On the left, you'll just get n, which is the point. We want to get all that number away. And on the right, we get 1 1/8. So n is less than or equal to 1 1/8. Okay, and then we need to graph that inequality. So I put 1 1/8. Since I have less than or equal to, I'm going to color in my point. I'm going to have a closed point because it includes 1 1/8. And then since it's less than, I'm going to go in the left negative direction. So that's why I get 1. That's why I get it pointing towards the 1, which is less than 1 1/8. Okay, so if something that I just did there doesn't make any sense, you should take this as a time now to raise your hand, ask me, try to make me in person explain it to you. Okay, but we should be okay with that around at this point. All right, now we're going to try the word problem practice. That'll be the last one we do. So Eleanor is driving below the speed limit on a highway. We can see the speed limit is 55 miles per hour, and she is going 43.5 miles per hour. Part A, write the inequality to show how much faster Eleanor can drive without going over the speed limit. Okay, so let's annotate this. I have a limit. And if I remember from my back, flip the page over, when we saw limit, that means that's like a maximum. And what maximum tells me is it's the less than or equal to sign. Right? It needs to be less than or equal to my limit, which is 55. So that's my maximum speed. However fast Eleanor is going, it has to be less than or equal to 55. Okay, and then what else do we know? Well, our current speed is 43.5. And then it's saying how much faster can she drive. So we're going to add our variable x, where x is representing how much faster she can drive. So I'll just put that over here to the side. X is how much faster. Right, so just in the top of my head before we solve this inequality, she could go 10 miles faster, 10 miles per hour faster, because 43.5 plus 10 is 53.5. So that's still less than or equal to 55 miles per hour, so that one's going to be good. 2 miles per hour faster, she'd be at 45.5. That's still less than 55, so we'd be good there. So now we're going to solve the inequality to figure out all the possible solutions. How much can Eleanor increase her speed by? Okay, so I'll rewrite my equation. 43.5 plus x is less than or equal to 55. Here I have x, and then I'm adding 43.5, so I have to undo that. So I'll first just rewrite what I have. And then I'm going to undo adding a 43.5 by subtracting 43.5. Do that to both sides. 43.5 minus 43.5. Combine those like terms, we just get 0. Like we always do, like is the goal. And on the right, we have 55 minus 43.5. That comes out to 11.5. So our solution, or solutions, is x is less than or equal to 11.5. So she can drive 11.5 miles per hour faster and still be at that limit. She could drive 11 and be under the limit, 10 and be under the limit, 8.72 and under the limit, right? So that's what we're getting. She can't drive 12 miles per hour faster because that's going to put us over the limit. So the different thing about inequalities is there's not just like one solution, even though this looks like one answer, right? It's all values of x that are less than or equal to 11.5, which is why when we graph our solution, we don't just have a point, but we have like a ray that's going off in one direction. All right, so even though the problem doesn't ask for it, let's graph that over here. So I'll put 11.5, and then I'll put 12.5 here, 10.5 here, and it's less than or equal to. Okay, so it's a closed dot since I have the equal to, and then we said it was any value that was less than 11.5. So that's going to be our solution. Based on timing, Ms. Deliotis will just tell you to keep going or to stop here, but you can start working on the additional practice. Are you ready for more? And ask Ms. Deliotis if you need any help as you get to these at the bottom.